Welcome to today video lecture series. In this video, we will discuss about heat transfer applied to in aerospace engineering. So, this is the introduction of a combustion chamber. So, the combustion chamber is a part of an engine where the combustion of fuel air occurs, producing high energy gases that propel the vehicle. And importance of combustion chamber is critical for engines like rocket engines, jet engines, and gas turbines, and handles extreme temperatures and pressures to produce thrust. And key parameter are its ranges up to 3500 Kelvin. Materials must withstand high thermal stress. And challenges in combustion chambers is the combustion temperature. It generates extreme heat, leading to temperature beyond material limits. And thermal stresses is differing temperature zones in the rocket and the chamber cause stress and landing to potential failure. And it's a material degradation at a high temperatures. Chamber walls can erode, melt, or oxidize, leading to damage. And cooling necessity, and it's to avoid structural failure or maintain engine performance. Efficient cooling methods are required. And type of cooling techniques, a thin layer of coolant is injected along the inner surface to form a protective layer between hot gases and chamber walls. And transferring cooling, the coolant is passed through porous walls, creating a cooling film by flowing through the material. A regenerative cooling, fuel is circulated around the chamber walls to absorb heat before combustion, cooling the walls and preheating the fuel. Ablative cooling, a sacrificial material on the chamber walls vaporize or melts to absorb heat, protecting the underlying structure. And film cooling, coolant gas is injected near the chamber walls, creating a thin, cool barrier between the hot gases and the chamber surface. Advantages, it's effective in controlling high surface temperatures, simple design, widely used in gas turbines. Disadvantages, coolant film reduces efficiency by mixing with the combustion gases, can be difficult to achieve uniform coverage. And a transpiration cooling, and its coolant flows through a porous wall and forms a protective layer over the inner surface of the combustion chamber. Advantages is more effective cooling than film cooling, as it uniformly covers the surface. Reduce thermal stresses on chamber walls. Disadvantages, it requires special materials for the walls, increasing cost, complex design and fabrication. And regenerative cooling, it works up to is circulated through channels around the combustion chamber, absorbing heat before being injected into the combustion process. And advantages, high efficiency due to dual functionally cooling and preheating fuel, widely used in rocket engines. Disadvantages, complex plumbing and fabrication, requires careful design to avoid hot spots or flow issues. Ablative cooling, the chamber walls are coated with an ablative material that absorbs heat and vaporize, carrying heat away from the chamber surface. Advantages, effective in high temperature environments such as rocket nozzles. Simple design can be used for single-use system like rockets. Disadvantages, ablative material is consumed, making it impractical for long-term use, and requires periodic maintenance and material replacement. And comparison of combustion chamber, it is based on technique, efficiency, weight, complexity, and cost. And techniques, it's a regenerative, high, medium, high, and high. And the film it's a medium, low, medium, and medium. And transpiration is high, medium, high, high. And ablative is a medium, low, low, and medium. And radiation is low, 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 and low. So this is the comparative study of heat transfer techniques in combustion chambers with respect to the temperature and with respect to the type of cooling technique and the type of film cooling technique and the types are transfer cooling, regenerative cooling, and ablative cooling. So the combustion chamber process with involved and with its radiation into the another form is in the final one is in a comparison with respect to the below technique, efficiency, weight, and complexity and cost of the regenerative production material. So in this diagram, it shows about the expansion ratio with respect to the area of exit to the area of throat of the this section. And also it indicates the this diagram which indicates the what is the part of the throat part and what will be in the exit part of the ablative cooling methods. So this is the finalized comparative study of gas turbine engines in aircraft heat transfer techniques. Thank you.